Hello, hola, and privet geometry students. Today we're going to look at Module 3, Topic 2. This is actually Part 2. Doesn't say it, but this is Part 2 to statements, conditions, and biconditionals. The standards are the same as they were for Part 1. So LT 4.3, identify and accurately interpret if then, if and only then, if and only if, all and not statements. Find the converse, inverse, and contrapositive of a statement. And also LT 4.10, judge the validity of arguments and give counterexamples to disprove statements. The objective for this lesson, you guys are going to write and analyze compound statements by using logic. Excuse me. Alright, the bell ringer. I'm going to pause 3 seconds, let you pause the video, work this, and then come back to me. Okay, the bell ringer. Find the counterexample of the following, if possible. If n is a real number, then n plus 2 is greater than 2. Alright, so if n is a real number, so let's just plug in 1 here. So 1 plus 2 is 3, and 3 is greater than 2. Let's see, but what if we plug in negative 1? Negative 1 plus 2 is 1, and 1 is not greater than 1. So we'll just say n equals negative 1. That's our counterexample for that one. Part B, if n is a real number, then n squared is greater than n. And actually, the negative 1 would work here, because if it's squared, 1, no, actually that wouldn't work, because negative 1 squared is 1, and then if n is negative 1, 1 is greater than negative 1. But what if n is 1 instead of negative 1? So n squared is 1, and n is 1, and 1 is not greater than 1, so there's your counterexample for that. Number 2, excuse me, write the inverse of if an object is red, then it is not blue. Remember back to first half of this lesson, the if, that's going to be our P, and then that's going to be our Q, and the inverse is not P. If not P, then not Q. So we're going to negate both of these, but keep them like they are. So we'll say if, excuse me there, if an object is not red, then it is blue. So we had to negate both. Oop, off the page there. So this said if it's red, so not P would be if it's not red, then it's not blue is Q, so not Q would be that it is blue. Alright, let's move up the page a bit. Start our guided notes. I'm going to do a reminder of the different types of conditionals that we've talked about already. So if-then statements, that's a compound statement of the form if P then Q, where P and Q are your statements. It's going to be written like if P then Q. And this is the same example we had in the first half, but I'm glad to see it again. So if it rains, then the parade will be canceled. If P, then Q. Converse, it's formed by exchanging the hypothesis and the conclusion. So the converse is Q, if Q, then P. So parade was Q. If the parade is canceled, then it has rained. Okay. Or an inverse, excuse me, that's formed by negating both the hypothesis and the conclusion. So if not P, then not Q. So P was rain, Q was parade. Notice here we have not. If it does not rain, then the parade will not be canceled. Inverse, negating both statements. And then finally, contrapositive. That's formed by negating both the hypothesis and the conclusion of the converse. So we flip-flop Q and P, but we're taking the not of both. So if not Q, then not P. Parade was our Q, so it goes first. Rain is our P, it goes second. Not and not. Just trying to get us on board here. If the parade does not get canceled, then it does not rain. Hopefully this is kind of making sense. Okay, let's see here how well we can see the. Just a little bit further. There we go. Okay. Number 1. Identify each if-then statement as a converse, inverse, or contrapositive of the original statement. So our original statement is if Carrie is on the track team, then she will make the flag football team. So this is our P, this is our Q. So first they give us if Carrie is not on the track team, then she will not make the flag football team. So track team, so not P, not Q. Looking up above, not P, not Q, that's the inverse. Okay. If Carrie makes the flag football team, then she is on the track team. So flag football over here was Q. There's no not. She is on the track team, P. So P then Q, you can't see it, but this is the converse. If you look up on your page though, you'll see that this is the converse. Okay? And then lastly, if Carrie does not make the flag football team, then she is not on the track team. Flag football again, Q, and that's a not, so not Q. There's a not, and this was P because it was the track team, so not Q, not P. That's the contrapositive. Pause the video here. I'm going to wait 3 seconds, then we'll do the you do, but try that one on your own first. Alright, number 2. Identify each if-then statement as a converse, inverse, or contrapositive of the original statement. If a shape is a quadrilateral, if a shape is a square, I got ahead of myself. If a shape is a square, then it is a quadrilateral. So square is our P, quadrilateral is our Q. That'll make that easy. Okay. So now let's look at our first example here. The shape is a quadrilateral. Q, then it's a square. That was the P. Q then P is the converse. We just take the opposite. We just flip-flop Q, P and Q. Okay? Q's up a little better there. Okay. Example 2. If a shape is not a quadrilateral, then it is not a square. So we have a not and the Q for quadrilateral and not. P was square there, so this is not Q, not P, and this is the contrapositive. Contrapositive, again, where we negate both and then we flip the Q and the P. So lastly here, the shape is not a square, then it is not a quadrilateral. So we have a not. Square was P, not Q was quadrilateral, not P, not Q is the inverse. Okay, flip over here for just a moment. page 10. Number 1, I do. I'm sorry, number 3, excuse me. Consider these two statements. So they give us P statement is a square is round. And then the Q, vertical angles are congruent. Select all the true statements. So firstly, we need to talk about these two. So is a square round? No. So that is false. Vertical angles are congruent. Hope you guys remember vertical angles are created by two intersecting lines. And those two would be vertical angles, and they would be congruent. And these two would be vertical angles, and they would be congruent. So this one is a true statement. All right. So P is false, Q is true. Not P. Not P is going to be the negation of this. This is false, so it makes it true if it's the opposite. Okay? All right, not Q. Well, if Q was true, then not Q is false. I'll just put that in blue. Okay? P and Q. Think back to the previous half of Sorry about that. So remember back to the previous half of this lesson. P and Q. And means both P and Q need to be true. Well, P is false, so this is already not working. It'd have to be both true there. All right, so what about not P? So if P is true, then not P is true. And Q is already true, so you got two trues, so this one's a true. All right, and then lastly here, P or Q. And remember, or means one or the other. Well, P was false. Q was true, so not Q is false. So this one's not good. Before we go over to number 4 there, I'm going to show you this, and I'll make this on the board in class. But if you guys are taking these notes, let me see. Actually, just take a look at this. We'll talk about this more in class. But here's a little truth table for us. So if the P statement is true and the Q statement is true, that makes not P false, because it's the opposite. Not Q false, again, opposite. P and Q, they both have to be true. These two are both true, so it's true. P or Q means one or the other, and they're both true, so it's true. Said I know this may be a lot, but I wanted to show you this, and again, we'll find a place to put this in our packet. All right, so if P is true and Q is false, then not P is false, because again, opposite. Not Q is true, because again, opposite. P and Q together, well, they're not both true, so it's false. P or Q, one of them is true, so it's true. Same thing here, we flip-flop. P is false, Q is true. If P is false, then not P is true. If Q is true, then not Q is false. They're both of them aren't true, so together they're false. But there is one or the other, so or is true. Down here, last example, P and Q both being false. Not P, not Q both have to be true because they're the opposite. P and Q false. P or Q, they're both false, so false. All right, number 4, you do. Pause the video here and then try to handle this yourself, and then unpause. I'm going to wait about 3 seconds. All right, number 4, consider these two statements. A hexagon has 6 sides. And the Q statement is the sky is yellow. Well, a hexagon does indeed have 6 sides, so that's true. I don't know where you guys live, but where I live, the sky is definitely not yellow. So, our P is true, our Q is false. So now let's see, not P. And, you know, we we could probably write these in here, but I'm okay with you guys just doing whether they're true or false. Just make sure you understand that that means not, and we're taking the opposite. So not P would be a hexagon does not have 6 sides, and that is not true because a hexagon does have 6 sides. Q, not Q would be the sky is not yellow, which is true. P and Q, remember, both have to be true for and they're both not, so false. Not P, a hexagon does not have 6 sides, which is false, and Q is already false, so that one's not true. But what about P? It has hexagon has 6 sides, that's true. And for an OR, we only need 1, so we can go ahead and say that this is true, but just for giggles. So not Q, the sky is not yellow, so that would also be true. So either way, the OR meaning one or the other, so we were good with the P being true. And our guided notes, again, we're on page 10. Give me just a moment to write this in. Alright, you can use logic and biconditional statements to indicate exclusivity in situations. For example, a square is a parallelogram with all 4 sides and all 4 angles congruent. You can express this as 2 if-then statements. If a parallelogram is a square, then it has all 4 sides and all 4 angles congruent. You also say if a parallelogram has all 4 sides and all 4 angles congruent, then it is a square. Biconditional statements. A biconditional statement is a conjunction of a conditional and its converse. It is true if the conditional and its converse are both true. Let me highlight some stuff here for you. So it's a conjunction of a conditional and its converse, and it's true if they're both true. We have symbols. The symbol is a arrow going both directions. It's read P if and only if Q, or P if with an extra F, so if Q. So the biconditional statement, for example, above is a parallelogram is a square if and only if it has all 4 sides and all 4 angles congruent. Later, you'll use biconditional statements as well as conditional statements and their converses to prove relationships. And as I told you guys in class, this is all setting us up to start writing proofs. Trying to get your mind right for that. Down so we can fit the bottom of the page in here. Okay, bottom of page 10. Number 5. Identify the truth values of the conditional and its converse, and if possible, write a biconditional. So we're going to put what we just learned into practice. So our conditional says, if 2 lines are parallel, then they have the same slope. We know that if that's absolutely true. So the converse for this, so this is our P, this is our Q, so let's just flip it and say if 2 lines have the same slope, then they are parallel. Alright, so is that true? If 2 lines have the same slope, are they parallel? Yes, this is also true. So the conditional and the converse are both true. And so right here it says, can a biconditional be written? Up here it says we can if the conjunction of a conditional and its converse are both true. I'm pointing like you guys can see above the screen, excuse me. It can be written, so the answer is yes. And let's write the biconditional. So our biconditional for this is going to be two lines are parallel if and only if they have the same slope. Okay, does that make sense? All right, number 6 is an I do. It's a you do. I'm gonna go quiet for 3 seconds, let you pause here, try to work this out, see if that's true, the conditional is true, then write the converse, and then determine if it can be if a biconditional can be written, and try to write it. All right, number 6. Identify the truth values of the conditional and its converse, and if possible, write a biconditional. So, if a triangle is a right triangle, then the Pythagorean theorem can be used. Absolutely true. Now, converse of this, again, this is your P, this is your Q, so we'll say if the Pythagorean theorem can be used, then the triangle is a right triangle. And this is also true. Just kind of separate the sides here so we don't get confused. All right, now can a biconditional be written? And of course the answer is yes, because both are true. For this one, a triangle is a right triangle if and only if the Pythagorean theorem can be used. Okay? All right, number 11. Top of page 11, we have 2 more problems, 1 more I do, you do. Then we'll start. Your independent practice starts on page 11 and finishes up at the bottom of page 12. I'm just going to put it like this. This is your homework. I told you guys in class, if you watch the video over the weekend, you get extra credit. So come in Monday, and if you've gone to here and we do the independent practice together, I'll give you extra credit. If you'll go ahead and work the independent practice before class, then I will give you extra credit on that. Just trying to get a little bit ahead, as much practice as we can, so keep that in mind. And if you guys are watching the videos, on the next video I'm going to put a word in there somewhere in the Module 3, Topic 3 video, and if you have the word on your packet when you turn it in, that's extra bonus points. So stay tuned. For now, page 11, number 7. Identify the truth values of the conditional and its converse, and if possible, write a biconditional. So the conditional says if a shape is a square, then it's a rectangle. So again, this is your P, this is your Q, and this is true. This is true. If a shape is a square, then it's a rectangle. A square is a special type of rectangle. Now, the converse for this would be Q then P. So if a shape is a rectangle, get tight over there, sorry, then it is a square. Alright, so the converse here, if a shape is a rectangle, then it's a square. A square is a special type of rectangle, but a square is not the only type of rectangle. So if a shape is a rectangle, then it's not necessarily a square, so that makes this false. So, can we write a conditional, biconditional? I hope you said no, because the answer is no. Why? Because they're not both true. Number 8 is the last you do. I'm going to wait 3 seconds while you pause the video to work it, and then unpause, and we'll check your answer against what we have. All right, number 8. Identify the truth values of the conditional and its converse, and if possible, write a biconditional. All right, conditional. If two angles are vertical angles, then they are congruent. Remember back just the previous page, I believe we talked about vertical angles. And vertical angles are created by two intersecting lines, and yes, they are congruent, so this is true. Again, P, Q. So our converse, this time I'll write it in red. If two angles are congruent, now I'm writing the symbol instead of the word, and I want you guys to do that too, because I want you guys to just know that's what congruent means. Congruent and equal, equal is for the numbers, congruent is for the shapes, but I want us to just know that this means congruent, and congruent means equal when we're talking about angles. Okay, off my soapbox. If two angles are congruent, then they are vertical angles. Alright, so off the page. Sorry about that. Just do that. Okay. So if two angles are vertical angles, they are congruent. That was true. Now if two angles are congruent, then they're vertical. So are all congruent angles vertical angles? No. So this is false. Can a biconditional be written? No. Alright, this finishes up part 2 of Module 3, Topic 2, Statements, Conditionals, and Biconditionals. Have a good evening. We will see you guys in class next time.